So next video is Higgs Boson Field Particles, London Equation, Superconductor Meissner Effect. Quote from Wiki, and this was filmed August 20th. It was researched August 20th, today September 17th, 2012. The London Equation, developed by brothers Fritz and Heinz London in 1935, relate current to electromagnetic fields in and around a superconductor. Arguably, the simplest meaningful description of superconducting phenomena. They form the genesis of almost any modern introductory text on the subject. A major triumph of the equations is their ability to explain the Meissner effect, wherein a material exponentially expels all internal magnetic fields as it crosses the superconducting threshold. So there's a diagram showing the Meissner effect. As the material drops below its superconducting critical temperature, magnetic fields within the material are expelled via the Meissner effect. The London equations give a quantitative explanation of this effect. August 25th, 2012, my thoughts. Just looking at the data, and I'm going to take the keywords out of it and create another formula for you to try. The formula keywords are the London equation plus relate, plus current, plus electromagnetic field, plus the Higgs field, plus the superconductor. See previous formulas for which superconductor to use, plus Meissner effect, I'm going to Google that, plus the London equations, plus quantitative mass, plus explanation, plus Higgs Boson Experiment, plus effect. My thoughts. I'm going to look at Meissner effect to see what it means. Quote from Wiki, the Meissner effect is an expulsion of a magnetic field from a superconductor during its transition to the superconducting state. Quote from Wiki, they detected this effort only indirectly because the magnetic flux is conserved by a superconductor when the interior field decreased, the exterior field increased. My thoughts on formula. Replace the Meissner effect with increased exterior field plus quantitative mass. Google quantitative mass to see what you get. Remember the earlier keyword in the last blog post was spectrometry? Look what comes up, quantitative mass spectrometry. Okay, and it's a PDF file from Carolina Kranzika for personal use. Do not read it without the author's permission. So it says google.ca. I couldn't actually look at it because she said you can't do that. So you'd have to look at that link in order to look at what she has to say. Quantitative mass spectrometric multiple reaction monitoring assays. That's from www.ncbi.nlm.nih.gov. From L. Anderson, 2006. Quantitative mass spectrometer to multiple reaction monitoring assays for major plasma proteins. And that's from the Plasma Proton Institute, and that's on Google. So protein labeling by iTrack, a new tool for quantitative mass spectrometry in protonium. Research from Wise S, Riegold K.A., Meyer H.E., and Warschild B. From Root University Bochum, Germany, from March 2007. The abstract is a novel MS-based approach for the relative quantification of proteins, relying on the derivatization of primary amino groups in intact proteins using isobaric tag for relative and absolute quantitation. iTrack is presented. Due to the isobaric mass design of the iTrack reagents, differentially labeled proteins do not differ in mass. Accordingly, their corresponding proteolytic peptides appear as single peaks in MS scans. Because quantitative information is provided by isotope-encoded reporter ions that can only be observed in MS spectra, we analyze the fragmentation behavior of ESI and MLDI ions of peptides generated from iTrack labeled proteins using TOF or QTOF instrument. We observed efficient liberation of reporter ions for singly protonated peptides at low energy collision conditions. In contrast, increased collision energies were required to liberate the iTrack label from leucine side chains of doubly charged peptides, and thus to observe reporter ions suitable for relative quantification of proteins with high accuracy. We then developed a quantitative strategy that comprises labeling of intact proteins by iTrack, followed by gel electrophoresis and peptides MS analyses. As proof of principle, mixtures of 5 different proteins in various concentration ratios were quantified demonstrating the general applicability of the approach presented here to quantitative MS-based protomagnetics. August 25th, my thoughts. Isobaric tag for relative and absolute quantitation, I track. I track is the key word, separate the plasma in the Higgs field. So we're going to do mass design plus reagents. So here's the formula. Mass design plus reagents plus proteolytic peptides appear as single peaks in MS scans, plus the Higgs boson signal single peaks, plus the MS spectra plus ESI plus MELD plus ions plus peptides. Are they in Higgs at all? Plus Google peptides Higgs boson. I want to see if they're in there. Keywords: the Higgs dubbed the God particle is believed to confer mass on matter. That's from phys.org. Artificial molecule called a stapled peptide that can. So it did come up. And it says Higgs boson, and there's the search thing for Google. So thank you for watching. We'll go on to the next video now.